Hi there. Thanks for joining us on Shaping Tomorrow. I'm your host, Art Morrish. In this podcast from TII, the Technology Innovation Institute, we chat with world-renowned scientists, technologists, and researchers to understand what's happening in the ever-changing world of science and technology in order to see how it affects our everyday lives, today and tomorrow. In our third episode, we're going to talk about the new frontier, something many scientists refer to as wireless cognition, the convergence of AI and telecommunications, otherwise known as 6G. 5G may have just started. However, our demand for IoT devices and technological advances continues to rise. So let's look into the future of data-fueled cities, future networks, and what it really means to have a smartphone, since I think our smartphones are poised to go a whole lot farther than they have. These are all well on their way to becoming fundamental components for virtually all parts of our lives. Today, I'm joined by Dr. Mérouane, the Chief Researcher for AI and Telecom Systems at the Technology Innovation Institute, TII. He will be answering everything we need to know about the developments of 6G. Dr. Mérouane, welcome to Shaping Tomorrow. Let's jump right into this. But first, can I call you Mérouane?
You can call me Mérouane, of course.
Okay, thank you. So as the newest chief researcher of the newest research center, can you give us a little bit of an idea about what it is you intend to do with this AI and telecommunications systems? That's a big portfolio. What's your intent on that?
Yeah, so totally right. So we're establishing a new AI and telecom system research center here in TII. Mm-hmm. And one of the reasons we decided to call it AI and telecom is that we're seeing today convergence of communication and computing, and they cannot be separated apart in the sense that today we're seeing more and more AI embedded in devices, in the cloud, on the fog, in many places, and you need to connect these intelligence together. And one of the main reasons we decided to put into place is that we think that we can leverage basically from the benefit of having a telecom, I would say, platform and an AI platform. The center that we're trying to establish has two kinds of directions. One is what I call business-driven research, trying basically to solve existing problems which are coming up from the different centers, which are already at TII, but also external stakeholders. And it's mostly about problems which are well-defined and for which we're going to bring either on-the-shelf solutions or trying to develop some new solutions to our problems. The second step, which is I think much more challenging, is to come up with problems and solutions.
Okay.
And so this is like a more long-term, I would say, task on which basically you start creating what we're going to be talking about, typically 6G, for which we don't have a clue yet what's going to be, but I hope I'm going to convince you that there are some paths around that, but also in AI, for which basically today we're at, I would say, a very low level of intelligence compared to what we would like to have in the future.
Okay. Well, let's start with 6G. You know, the whole idea of wireless cognition is just fascinating. And I think some of our tech-savvy listeners out there are going, okay, what does that mean for my smartphone? What does that mean for my Alexa or Google or Amazon Dot or, whatever the cool device of the day is, Is this science fiction or how are you going to make this practical?
So it's not science fiction. First of all, I think we should tell to the people who are listening to us, what is a G? A G is a generation. And so we're going to the 6th generation. And you have to know that the history of cellular has been going through generation with, I would say, more or less KPIs and targets that we have defined at the beginning. So if you go back to 2G, I'm going to leave 1G apart because nobody knows.
Cares.
Nobody cares. Nobody knows about it.
Yeah.
But 2G was one of the target was what we call mobile for voice, and for which we developed cellular systems, GSM being one of the most famous, and for which we have now a seamless way of communicating around the world. Then 3G came after around 2020 with the objective of doing what we call mobile for data, meaning having the ability basically to download data in any place in the world, also in a seamless way and going forward. And then 4G, 2010 came, 4th generation, mobile for internet, the ability to have exactly what you had as an ADSL or Wi-Fi experience outdoor when you move. 5G now is being deployed. It's getting a lot of hype, mostly about what we call mobile for things, where you have this massive connectivity being brought by IoT, which is a terminology called Internet of Things and for which you're building. And today we're thinking of the future, which is what we call 2030. And one of the things you mentioned, wireless cognition, is very important, is that we're trying to target what we call how to connect intelligence and doing mobile for machines, for which we'll know in the future we'll start having robots on which we have AI enabled in them. Robots being a car, being, of course, a smartphone, being basically things that you can have at home, which have AI, and basically for which you need to start building up the protocols. Where they talk to each other, but you will be also talking to them. And for that, there's a lot of technologies that we're forecasting which are not easy. We're talking about a smartphone. A smartphone in the future will not only have the ability to communicate, but will also have the ability to sense its environment. And it becomes like a portable radar. Perception, cognition, you need to see. And so we're building today basically the kind of technology that enables these objects to see around them. A car, autonomous car, is already starting to do that. When you think of a car, it's nothing else than a smartphone with 4 wheels. Okay? And we're building the connectivity around that, which is LiDARs, for example, which enables. So you want a car to be able to detect its environment to see. A smartphone is going to be doing that. When you start seeing, that's the first step when you start gathering a lot of information to start already processing and thinking, and for which then you start building some kind of protocols to communicate with other intelligent entities, and hopefully also the way we would be communicating and talking to a machine.
So it's not so much Siri is going to get any smarter, she's just going to get more perceptive.
It's going to be more perceptive by having an additional ability to perceive the environment. Then you will process that information to be able to start, that's the first step, to think, detect, talk, and ask. And so we're not at that level yet. And so there's a long road, such as 6G is going to happen, because the predictions are roughly around having 6G by the year 2030. Which means also that today 5G is being deployed, and it's going to be also being embedded with more technologies, because people are already talking about 5.5G by 2025, which are higher capabilities that we have today. And when you think about 5G today, people are mostly using the broadband experience. However, there's a lot of things related to localization that needs to be built. Latency.
Explain localization.
Localization means that basically you need to be precisely localize at least the things that are being embedded in factories, stuff like that, and for which basically you need the positioning of roughly
positioning to centimeters, not to meters.
Centimeter, which is totally crazy when you think of the difficulties we have of positioning each object. And this is extremely important for a lot of applications that we're seeing. Latency is another one. Today, when you ping a system, it takes a bit of time by the time you have some request. There's a lot of critical systems. Take autonomous car, for which things have to go fast. Take typically a car that goes at 100 kilometers an hour. By the time it sends a signal and brakes, today on a 4G system, it takes you roughly 3 meters of distance before it breaks down. With 5G, you're going to get at a centimeter level. And with evolutions, you're going to avoid any kind of accidents you can have. And of course, the last one also, which is important, is how you connect massively and reliably all these things. This is a big issue. Sometimes you lose your connection today. That's not possible anymore.
That was just where I was going to go. Thank you for the lead in, because I was going to say, the more intelligent the systems get, the more data they're moving, the bigger the pipe has to be. How are we going to handle moving all that data?
So that's a good question. So researchers are working actively in basically trying to communicate in what we call higher bandwidths, because this is where basically the frequencies are available to communicate. And so by going higher in bandwidths, of course, you have more available pipes in which you can transit basic information. However, this poses a lot of big challenges in terms of research, because when you start talking about millimeter wave, terahertz band, people get excited. One of the reasons that
they don't propagate very far.
Exactly, they don't propagate, so you start bumping into systems. So you need to find a way to increase the range of these technologies. People are working on ways of what we call beamforming, for example, trying to beam precisely, for which also
this narrow beam instead of omnidirectional.
Yeah, exactly. Today, and it has good features because it avoids. It becomes more greener in the sense that you don't start sending all the data everywhere, but on a specific direction. You increase the range, but it also poses difficulties because the majority of cases, as we know now, and this is why research is going on for the evolution around 5.5G, is in what we call the line of sight domain. Line of sight means that you see your destination. In general, when you do mobile communications, when your wife is calling you, she's not on line of sight communication.
Probably
you don't
not.
even know where she is.
Exactly.
So you need basically to establish some systems that enable this range of communication. And I think going into higher frequencies is providing a lot of opportunities. And also in terms of engineering, how you build up the device, how you miniaturize those devices is going to be a nice, I would say, challenge for researchers.
Okay. So let's pull back a little bit, because there was another comment that you made about sensing the environment and sort of a ubiquitous kind of sensing. Certainly I can see that for cars, for phones, maybe for some of the other Internet of Things, but there's a privacy issue that gets into that too. If I'm mapping everything, I know particularly in the EU, there's some pretty stringent regulations against that. So how do we do that balance?
Yeah, what you're talking about is a big issue not only for telecom, but in general for AI. What you're talking about is this GDPR issue, which is
define that, please.
Yeah, a GDPR is the data privacy, basically a program that has been established by the EU, in which basically, the data that is generated by some people or by countries should stay on that country and should not go outside. And because of all the problems that you're saying, and for which you also certify a lot of things to the people when you generate data to be sure that it's not misused by other companies. Because we all know that today, the big market is how you exploit that data and how you refine it. But, so that's a very good point. And so today, in the standardization process, we are trying to find ways so that we keep the data within, at least the data still is localized, and we don't transmit the data out of the thing. Let me give you a very specific example.
Okay.
Today, basically, when you are using AI perspective or exploiting the data, in general, what happens is that the data goes out from your mobile phone and it's hammered in a cloud, on which basically you start processing it, and then you start giving it a bit of meaning and taking a decision. Today, we're working a lot on what we call edge AI systems, on which basically the training and inference is totally done at the edge, and on which basically only the model is extracted and not the data.
Okay, so that helps privacy.
That helps privacy. Of course, there are some caveats with that, because basically the amount of data that you have on a mobile phone is not what you have on a cloud.
Right.
But still, smart people are building what we call distributed AI systems, federated learning systems, in which you extract the models from the different devices, and then you start building what we call some kind of aggregate model based on the different models. So you can exploit basically the data of others, but through the models that you can capture, which is not a great model, but at the end it becomes a very good model because you get aggregated through federated learning perspective. So this kind of work requires a bit of standardization, on which basically you know what can be sent on some kind of signaling patterns that you have things. And this is things that people are trying to devise in the releases that we have in what we call the telecommunication standard, which is called 3GPP, and on which basically we're trying to define what should go out from your phone to keep up the privacy.
Right.
But it opens up also a lot of very interesting issues in terms of, if I still have the model, can I do some kind of reverse engineering to be able to infer on the data? So we're trying to back up all these things at the moment, but we're fully aware, and I think the success in the future of deploying native AI networks on which you're doing what you're proposing is going to be dependent on the fact that we can ensure that people feel that their data is totally private.
Okay, that's amazing stuff. And you don't think about all of the political considerations that rapidly get wrapped around the technology considerations. So we've talked about sort of what the future could look like. But you said your center is focused sort of on long-term research and then on short-term projects. So give us a hint as to what a couple of the things, I know you can't tell us specifically, but give our listeners a little bit of a hint as to what you think is going to come out of the doors of the AI and Telecommunications Systems Research Center in the near future. What should they be expecting?
Well, the first thing that we're trying to build up already is what we call models which are trained. because we have a lot of data which is generated by our different centers. They're doing some outstanding job. And the issue today is that all the data that is acquired and also manipulated can, of course, train some models that will become stronger and stronger that then can be used for other perspectives. So this is something that we're focusing at the moment. Now, of course, in terms of what we called here the business-driven research and technology-driven, we're already starting to have talks with the Autonomous Robot Center to start building what we call AI-based self-organized network systems, in which basically these different entities, which are robots or drones, can talk to each other in a completely decentralized manner and be able to take joint decisions and converge on some joint decisions and not be directed by a central entity that tells them what to do.
So I've heard the term wolf pack kind of used along the lines, because you got a swarm, which is just completely decentralized usually. And then you've got a wolf pack where it self-elects the leader and may change the leadership from one entity to another. Is that what you're talking about for this? Or is there a nuance there I'm missing?
It goes in within direction, but it's much more general in the sense that whenever you have a system, a fleet, for example, of drones, and you need the self-organization, because if you lose one, then automatically the system has to reconfigure and know which one is going to pass automatically in front. And in general, you have problems of coverage in the sense when you're sending something far away, sometimes the communication is not good. So they need to autonomously take their own decisions on how to things. Of course, this is done through some kind of feedback information they have, and how they exploit it is based on what we call deep reinforcement learning algorithms, which takes into account, and it goes within a setting called multi-agent systems, because we're talking about multi-agents which are going, and you need to develop these systems. It's been a long time people have been working on that. Looking at techniques based on control, but not using basically an AI-based approach. And today, embedding the deep, I will not go into the details of the different things, but the deep feature of that, of course, gives you a lot of gains in terms of what you can do. There's also issues that we're tackling today that we want to tackle with the Advanced Material Research Center, which are doing an outstanding job on what we call smart environments, where they have large intelligent surfaces which are embedded on walls and stuff like that, and which basically can change the properties of propagation of a given environment. At the moment, there's no smartness because it's controlled specifically, but the question is how you embed these features with computing and basically propagation capabilities, so the environment decides on its own how it changes its properties, so that it provides better coverage, for example, in a room or somewhere.
Okay, so like an adaptable antenna, an adaptable reflective surface, that sort of
thing.
So let's go back a little bit though to the deep learning though, because that's something that I've been interested in. Actually, sponsored a few things back in a previous life looking at that. And one of the questions that always comes up is, how can you tell whether your learning set has been poisoned? And how do you test to make sure that your learning set is as robust as you can make it? So those are kind of two questions, but they're really interrelated, right? Am I learning the things is it learning the things I really want it to learn? And has somebody inserted something in there that I don't want, right? Yeah. So you have to be able to get at that. How do you test that?
So that's a very good question. We're still at the stage of research, meaning we have, of course, some algorithms which work, but we cannot at the moment bring you a proof that we're sure it's always going to work and how you do it. But what you're saying is totally right. We have, for example, today people were looking at what we call robust learning, which is basically I have some data. I have 10% of my data which was lost, but I don't know which one.
Right.
And still be able to have some robust learning on that. And so basically you need to build up some algorithms which are robust to what we call erasures. What you're talking about, even inserting wrong data could be part of that. I mean, you don't lose them, but you put them there. And so this is the kind of research that we're doing. And of course, there's still a bit of work in terms of understanding up to which level of, let's say, loss of data in your set you can still work out with the given algorithms that you have. We don't have a full understanding of that, but we have workable situations that we can test and can work out. And we know also in terms of the vision of your data that you're saying, what will be the training set and the test set on which you're going to play, which is also very important. Because usually what you do is that in every kind of neural network, let's say research, what you want to do is generalize, meaning you have a set of data. Okay, I train on that, but now I have a new set which is totally different from the ones. Can it still work? And this is one step ahead that is not still clear in this AI, I would say, research.
Okay. So I've heard and there's a bunch of terms for this, cognitive assistant, Radar O'Reilly, if you're a fan of the old MASH programs, where you have an assistant that resides on your phone or in your house or someplace like that can not just do what Siri does, which is you ask it a question and it goes out and searches a database and tries to give you an answer, but give you context for an answer and actually make suggestions. Course of action kind of suggestions where it says, Art, you probably don't want to do that. That's really, really dumb. You need to do this today, and because this is more time critical than what I really wanted to go do, even though it was dumb. Right. So is that something that fits within this paradigm of the smart systems that you're looking to release?
This requires a bit of a higher step than what we do. But what you're saying is historically true. Let's say that everything started, let's say, with more or less data mining. You just search.
Right. Yeah. It's just
something in a database.
How efficient your algorithm.
Yeah. Second step, what you do is some kind of what we call function approximation. You try to combine different things and basically, or you do what we call interpolation or regression between the things. And this is the thing which is a big hype today, where I think we're moving quite nicely in terms of within the kind of solutions, we try to create a new solution or a new question or a new answer or a new proposition based on a set of proposition by only by interpolating. And then there's a third step, which is more generalizing what you have. We're still not up to it. What I'm saying about this assistant is exactly in that realm. Yeah.
So I heard someone make the declaration, but there was nothing to back it up, that those kind of systems would actually be easier to train because they'd only have to learn me. Is that true or is that not true? Because I've seen that in writing in a couple of different places, and I'm not sure that I believe.
Well, in general, the more you pour data in your system and you crash it, the more you have a model trained, but with much more parameters that's going to happen. So of course, it's going to be better because it's going to get more insights.
More insight into me.
Than you, of course. And it's going to be getting also more contextual information. Because, in general, when you start defining something, you have two ways of defining it. If I want to define you, I can define, you have a beer, you have things. But one other way that I can define you is through your context. And it's true, the more you're connected to other people, it defines you. That's how Facebook works. It's a graph. So in a graph, what happens is that I can totally define you by your friends.
By my network.
Network. So, of course, the more I get a context, the better it is because I can start building on that context. And this is the best way to define. For example, if you want to do image recognition, you could recognize on an image if it's a dog. But if you have a background, which is the sea, then there's a problem because the context doesn't make sense. In water, a dog is not there. So, of course, this contextual information by bringing much more things helps in terms of improving the system.
So then they say it's probably a seal because a seal's head looks like a dog, but you would find that more likely swimming.
Today, the majority is taking an approach where you take the dog and you have many dogs which are rotated, blah, 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 and you always look at the dog. But you need to take into account the graph and the structure behind, and then you have a better kind of recognition that you do. Taking the structure of the graph requires new sets of algorithms that that the community is building right now.
Very cool.
So it gives you a bit of a set. Maybe also another point that I think we should mention also is that on the things of the crashing data that you were talking about, there is today, however, a big issue that we're starting to see is what we call the energy crash of AI. In the sense that to train those models that we're talking about, the amount of data that is required and the amount of energy that is being poured is a big question. And so we need to work out some more, I would say, greener AI techniques for which the community is tackling. Because today, AI is mostly brute force approaches. And by the way, if you look at what happens in the last 5 years in terms of breakthrough, all the different techniques that we're building, called it blockchain, all these technologies are more or less brute force techniques, which are having a huge impact in the global, I would say, CO2, carbon stuff. And I think this is, a big step that also needs to be taken by the community to be able to make more parsimonious, less data-hungry approaches, which will win because we won't need that much data and will also have an impact on the way we're building our society.
That's really great to to see that, somebody's thinking about how to drive down the energy footprint, if you will, of a lot of these things. Because you see the big server farms and everything like that. I've actually seen infrared images of them, and they're hot compared to anything else you may think of. Even on the outside, even though they're air conditioned, you're looking at the heat coming off of them from their environmental cooling systems and all that. So one of the things that I wanted to ask you is you've talked about a fairly wide range of research topics. Could you give me an idea of what you think a day in the life is going to look like at your new center? And also, since you're new, you're building your team, what kind of things should our listeners be looking at if they wanted to come and work for Professor Mérouane? What kind of skill sets should they have?
Well, for sure, I think a couple of things. I think what the center here is trying to build is some kind of disruptive thinkers, which are being able to at the same time work out applied research and having an impact on a quick win and also on a longer win.
Okay.
And I think the balance is not always easy. And I think you always need, it's a chemistry to find the right balance between, I would say, quick wins and long wins in terms of how you pour your resources. In general, the kind of expertise are people who are very good in fundamentals because that's what stays, whatever the situation. And then you apply them in different directions. So, of course, strong people or people who are strong in mathematics, which is at the heart of the algorithmic, I would say, hype that we're having today, is extremely important for our center. So, of course, I'm reaching out to people who have a very good background in, I would say, strong mathematical skills to be able to apply them here in our center, but also who have a good sense of engineering in the sense that they want to see their work translated into, I would say, things that will impact basically UAE here, but also all the world that we're seeing around us. On a type daily life, it's a good combination of brainstorming sessions, working in front of the computer by coding and implementing stuff, and also basically interacting with various stakeholders where we're having great collaborations, and we're going to kickstart these collaborations with university partners that we're having here, because the kind of influx is very important in terms of exchanges that we can have with the different, I would say, partners. And it's very important to feed us with ideas and exchanges that we have.
Wow. This has been just a real tour de force. Everything from smart cars to, more connected phones to more connected IoT to, the environmental impacts of brute force algorithms. This has been great. If I said, okay, you've got one last thing to say that I didn't ask a question on, what would it be?
Well, I think what we're building here is quite unique in the region. And this is, I think, one of the reasons I decided to join this fantastic team here at TII and also kickstart the work that we're doing. And I'm seeing a very international, I would say, motivated environment with a lot of very clever guys that basically want to have their work being done without all the I would say the level of bureaucracy that you could see in research, because this is something that people usually complain of. Bureaucracy. I don't want to spend my time just getting grants, funding.
Not the thing here.
And you want to focus on what you're smart in, what you can do, and we give you basically this whole ability to just focus on your work and make outstanding, I would say, contributions to the center and society.
Well, thank you very much. This is, like I said, just been an outstanding tour de force. I really enjoyed speaking with you. I hope you had as much fun as I did.
Great time. And I hope we can also extend that to a coffee outside next time.
Absolutely. I've got tons more questions I want to ask, but we're out of time. So I would encourage our listeners to make sure that you send us your questions. Thanks for stopping by. Anything that you want to have me answer, Professor Mérouane answer, or the rest of the team at TII, send them in. We read them. We will answer them. But for now, we'll see you next time.